Hi and welcome to the lesson about batch layer. So it may sound a bit strange because we are talking here about streaming approach of real-time approach of ingesting the data, but in fact you will always, well, not always, it's maybe too general, but most of the time you will not need to process data in real time to get the insight. Very often having an hourly latency will be just fine. And in order to process this data in hourly latency, so in batch manner, you will need to somehow synchronize your streaming broker with some data at rest storage, like for example, an object store. And what are the use cases? So the first use case is for the data reprocessing. So if you need to reprocess your data and you know that your reprocessing boundary, so for example, from 10 to 10:50 a.m., when you have a partitioned storage in your batch layer by this time, by this period, you can simply reprocess this data and target the specific data to include in this reprocessing logic. Whereas the streaming broker is, remember, an append only log, so it doesn't have any notion of event time or any other business meaning is attribute, and it will be much more harder to target the starting point for the reprocessing. And yeah, that's the first use case. Another one is for the data bootstrap, so starting a new environment. And here too, if you have some storage optimizations like partition the data store, or maybe you are using columnar data formats, then starting a new data set will be much more easier because you can easily target not only the specific time boundary thanks to the partitions, even though the partitions not necessarily have to be time-based, they only can be based on some other business attributes, like for example, I don't know, country of the customers or maybe country of your stores, but stuff like that. But generally, the event time is the most common attribute for the partitioning. I close the parentheses. And for the columnar formats, the columnar formats helps you to identify only the attributes, the columns you may need in the new environment, something which is not possible to do with streaming broker because remember, it's a flattened structure. It's only an array of bytes, in fact, for each value, and you will need to add a much more logic around that to bootstrap a new environment. Another thing is machine learning. So here too, it's much easier to process data is stored in at-rest storage, for example, in files in a columnar format. It will be much more performant because very often you will not need the whole row to train a machine learning model, even though it's not the responsibility of a data engineer, I agree, but still, data scientists will often require only a bunch of attributes that are relevant to the problem they're trying to solve. So here too, you can use this columnar format optimization to reduce the volume of data sent to the data science notebooks, to the machine learning notebooks. And finally, ad hoc analysis. So technically, it's possible to analyze data in streaming in an ad hoc manner, but you will be often limited to the time when your query starts. So you will not be able to go back very deep, very far away in the past. It's mostly for the real-time insight. Whereas if you need to analyze some trends for maybe a week or even a month, then it's much more easier to do with a data at rest storage, where I repeat again, you have this partition optimization, you have this columnar storage and all the optimization that can speed up the ad hoc querying. And the question is how to implement this batch layer. So there are two big categories of solutions. The first of them uses the buffering. So generally, whenever you have the records read, your data processing job stores them in an in-memory buffer that eventually can be checkpointed for fault tolerance. And now, if one of these conditions happens, so the buffer reaches the max size or the buffer time is reached, then at that moment the job will write the data to the the at-rest storage. And it's quite important to have both because you might have some trends in your data processing, and streaming data may have, for example, a huge volume during the day and a very low volume during the night. And without this max buffer time, in that case, you will wait probably until the morning to buffer and write the data in the at-rest storage, which is not optimal when you have some batch jobs behind reading data from maybe hourly partitions. Another approach uses more data processing native solution with micro batches. So for example, Apache Spark structured streaming works in micro batches, and how it always takes a bunch of records from the input. And now when you have a bunch of records, you can naturally checkpoint them at once into your data at rest storage. And of course, it works additionally with some checkpoint layer to know the last processed item. And there is also a variance for that with batch. So you can also have a batch job defined with streaming API, so with all this checkpointing natively managed by your data processing framework. And here, instead of running, for example, every 10 minutes, the batch job will take data from the last hour and obviously have a much more data to write in our data at rest storage. So, and obviously the more data involves higher latency and also much more compute needed here to get it and to write to the storage. And regarding the storage, data layout does matter, as you already know from this lesson, and there are different strategies you might have for this batch layer. The first strategy is very rudimentary, very easy. So you have your streaming job and you write data to a corresponding container. For example, here we have an Apache Kafka topic A, and we write this data to topic A subdirectory. It implies that all data is stored together, but it's easy to set up, it's easy to run, but on the other hand, it's very hard to use as a downstream for downstream consumers, because for example, if they need only the last hour of data, then they will always need to process the whole data set, and believe me, it will increase every hour, and your consumers will need much more compute power every hour to process this data, and it may also have some implications on the execution time. An alternative is the partitioned output. So the partitioned output, when we write data to some time-based subdirectories. So here you can see that we have hourly based subdirectories, and it has some ease for the consumption. So the consumer, if a consumer needs only 11 o'clock, it can simply target this subdirectory and get the relevant data to it. And this approach has a specific naming in data engineering. It's called partition pruning, so that the consumer pruns the irrelevant partitions and it can only process data it's interested in. But of course, this job must have much more logic to deal with these partitions and also handle this late data, because as you know, the streaming data and real-time ingestion involves some consumers going offline for a longer or shorter period of time, and during that time they will not send you the data, and you will need to integrate it somehow to the system to not lose it. So the easiest solution is to use the partition processing time, so the real time of the job. And with that, all the data will be put always to the most recent partition. However, if your consumers want to get data by event time, which is very often the case, because event time is more related to the business logic, processing time is more technical concept. So if the consumers need data in event time, they will still need to read a lot of partitions, less than if you had used the single storage, but still it's more than if you have partitioned by event time. So here we have an example for processing time partitioning, and we have at 10 o'clock, and the data for 10:20 will be written to the 10 o'clock partition. But for another record, when we, for example, are already at 11, data for 10:05 will be written to the partition with 11 o'clock, because this partition value corresponds to the real time, to the processing time. What happens for the event time? For the event time, it's much more consistent. So we still have 10:20 in the partition of 10, but now when we move to the 11 o'clock and we get this 10:05 data, we will add it to the event time partition of 10 o'clock. To compare both approaches, so this one with event time partitioning is easier for customers, requires, but on the other hand has some implication on the job, because it requires from the job to parse the data and extract the value. And in the parsing, things can go wrong. For example, you may have a malformatted JSON or any other format you are dealing with, and in that case you will also need to think about that fact, and for potentially add some dead letter storage. And another, and maybe the most important point, is that one partition can remain open for a long period of time, and it will always depend on your customers whether they will need to reprocess the partitions getting late data or not. From your side, of course, it also has an implication, because you will probably create small files with this late data, and you may need some compaction job to fix that issue and create bigger files to optimize the reading throughput for your customers. And as I already spoiled a bit, life is not all rosy, because things can go wrong. So here we have a JSON, and here you can see that instead of getting a JSON, our producer made a mistake and sent us a text format that we cannot process, because we wrote a job to process JSON data. And now we have two choices generally. We can either ignore the error or stop, so ignore the error and keep the job running, or we can stop the job and fix this issue, or add some try-catch block to catch this fact of having an unprocessed, unexpected format. But there is also a third approach with a dead letter store. So dead letter is something very common in data systems to indicate something storing data that cannot be processed or cannot be delivered. So here, instead of ignoring or stopping the job, we will simply catch this parsing error and send it to errors subdirectory with the data. That's the very important thing to keep in mind. This dead letter store has and stores real data. So here, even though we have some text, we may imagine that our customer uses old format of the messages that we don't support anymore in our job, and we have this real data, this customer data, in our errors subdirectory, and we may need somehow to re-ingest it to real pipeline to not lose it. Of course, it will always depend on the volume of the data. If you have a small bunch of records, maybe it's fine to simply ignore them, delete them from the dead letter store. But if you see that the ratio between your valid and invalid data is like 1 to 2, then 50% of data is it's a lot. So you may need to have a data re-ingestion job to this correct data storage. And it also has other implications than the re-ingestion. You need to have this monitoring and alerting layer on top of it to know the volume of data and to be aware that there is maybe some increase in this dead letter store. And obviously you will also need some ad hoc analysis capability to know what are the specific errors for this, because it's not always possible to detect the failure reason at this step. Sometimes it may be an exception, you haven't thought about it, and in that case you will maybe need some human investigation on that part. And yes, that was quite a long lesson, but as you see, even though the batch layer is mostly about putting streaming data in some data address storage, it has some challenges with event time store, with late data, with invalid data. And all this explains why this lesson was so long compared to the previous ones. Thank you very much and see you in the next lesson.